What is up, everyone? Today we are taking another look at Kubernetes security. So when we think about that diagram we had at the end of the last video of the control plane, the nodes, the pods, at a high level, a lot of Kubernetes security is about protecting each of those layers in the best possible way. The first layer we're going to talk about is that control plane layer. And there's a lot of different tools out there that it can be really confusing because they all take different approaches to the same problem, which is how can I scan to make sure that my configuration of these resources is secure? So we're going to go ahead and alter our deployment of OWASP juice shop in order to make it intentionally insecure with a few different things. And then we're going to test a few different tools along the way to see what gives us the best results. Hey everyone, James from the future here. I realized going into the video that I actually didn't explain the tests that I was doing up front. And so it made it a little bit harder to understand along the way what I'm doing. So I want to just explain those really quickly, the 5 high-level tests that we're going to be doing against these different tools to understand Kubernetes scanning and how it works. The first is hard-coding environment variables into the deployment. So if I go into the juiceshop.yaml here, you'll see I've hard-coded environment access keys. This is a super insecure way to have it so that your container can access other AWS resources. Instead, what you should be using to accomplish this is URSA, which is IAM roles for service accounts, which does some magic behind the scenes to basically do this using short-lived credentials that are mounted inside of a container instead of just hard coding these in here. This is extremely insecure to do. So that was the first example, and I did that because it's not something that you would expect most scanners to find, because it's not strictly speaking a misconfiguration with the cluster per se. It's instead just something within the YAML itself that's a common misconfiguration to do. The second exploit is insecure cluster role bindings. Now, this insecure cluster role binding is being done through this cluster role binding here, which is referencing the juice shop role. And if we look at that juice shop role, we'll see that it has the ability to do anything on pods, service accounts, and the service account token. Essentially, this means that this role, even though all it has access to do is create service accounts, it actually has the ability to create admin accounts that can then do whatever they want from there. So this is a great pivot point into other things. And Armo has a RBAC visualizer that can help visualize this, which is why I wanted to test that. And it's just another good in-depth common misconfiguration error, because it can be really hard to track all of the service accounts and what they're doing, especially if you're configuring them through your deployment YAMLs. So those were the 2 that are in the initial tests. And during the video, you'll see me add these additional things. The third is mounting the Docker socket. And what this is where you mount a path to the Docker socket. And what this might be done in the case that someone's trying to use Docker from the container in order to launch new containers on the host. So something that's really janky, but sometimes in applications, janky stuff happens. So here's an example of what that command would look like in an exploit, where you're using your access to the root host to launch a new Alpine image in a privileged container. So this would basically give you God mode access to the node as a whole once you had done this. And so this is, again, it's not super common that I've seen to mount the Docker socket here, but this is a very common misconfiguration as far as being able to access files in general on the node. And that's why I added this test. Fourth, exposing port 22. This particular test is something that, again, I wanted to test the contextual understanding of these apps. And so the port 22 is by itself not something that screams a security issue in the sense that you might purposefully be surfacing an application that can do things on port 22. However, in general, you would see, especially if I'm surfacing something on port 8000, port 3000, these ports are more typically used for web application testing, gRPC calls between services. It's not typically something where you would see port 22 open. So I wanted to see if anything would catch that as a potential security issue. And finally, privileged container. This is the thing that I expect everything to catch because it has become the ultimate meme of don't do this because a lot of legacy deployments have this. And so I'm just forcing it true here. And there's ways to prevent this at the admission controller level where you force a policy saying don't allow any privileged containers to run. But really, I wanted to just force it here as a way to test that the YAML is getting scanned itself. And so these are the 5 things that we're doing to test the Kubernetes vulnerability scanning throughout this video. And let's jump right into testing the first tool, Armo. So this is Armo, and it's the first tool we're going to be taking a look at today. I really like Armo because it, first of all, is based on a popular open source tool called Kubescape. I've also talked to them a little bit in the past. Really, they're just a group that is very concerned about Kubernetes security in general, and really I think is doing a lot to lead in this specific space of scanning Kubernetes clusters. They have this sick loading screen where we're blasting on in, and we're going to go ahead and set up our Kubernetes cluster here. So this is just a simple Helm install. So first we're going to install Helm via brew, and then we are going to, once that's done, install Armo into our cluster. So Armo runs as a few different things. It deploys a lot into our cluster. We'll go ahead and add the repo here so we can take a look at what it is doing in cluster. So you can see it's just installing, wishing me good luck in my helming adventures. So what it's doing here is making a namespace first and foremost, and installing within that namespace. We will take a look here in a second. So let's go ahead and get the namespaces to see. We have our Kubescape namespace, which is what we've just created, and then the default namespace is where our Juice Shop app lives. So if we load the pods here within Kubescape, this is showing us everything that's within here. So if we pause here for a moment and just take a look at everything that's here, it'll give us a better idea of what we've just deployed to our cluster. So we see this gateway, which we can assume is probably being used to forward logs up to their SaaS platform. So something to keep in mind is there's probably an external connection happening here, as well as an internal for them to scan our cluster. The collector, I'm assuming, is taking in log data, whether that's from the containers or the Kubernetes audit logs, is important from the standpoint of understanding what a tool is doing. Is it looking at the audit trail from Kubernetes itself, or is it looking more holistically into the container logs? Kubescape, we know, is the open source vuln scanner, so it's just, if we wanted to run the free version, we'll take a look at that. But the vuln scanner is there. Kube-vuln, I'm not sure what that is. We can assume it's something that lives alongside it. The node agent, I'm assuming, is the daemon set that's actually deployed on the nodes. And that node agent is probably what's collecting, maybe it's alongside Kube-vuln, what's actually looking into the container images themselves for vulnerabilities. That's a feature that I'm aware that Armo added. Operator, collector, and storage, those are probably just different pieces to make everything work together. So we can see this is not a super lightweight deployment. It's doing quite a lot here. But it is all segmented to the namespace. I'm assuming all of these are as a daemon set where they would deploy across every node, which has some different resource considerations. But that's a high level of what's getting deployed here. So now let's go ahead and hop back into the tool itself here and verify our installation. And it sees that it was added correctly here, and then did a little error, but now our cluster is connected back into ArmoSec. And the first thing we can do is see our test cluster here and the controls that are failing, and take a look at the different compliance frameworks that it's scanning for. So this is the main thing that I would recommend Armo for, is looking at these different control scanning frameworks. And so really within Kubernetes, there's a lot of newer frameworks to take a look at once we get through this onboarding tutorial. Where we see MITRE, NSA, all controls. So there's a lot of different controls getting scanned. And first, let's just take a look at what we see here. The resource limit and CPU limit is not set. We have host PID privileges, which is where containers have access to different pieces of the host. But really, just looking at some of these things, it's detecting places where we have not implemented controls where we could have. So this is always funny when tools detect their own deployment issues. Now, if we go in the vulnerabilities, this is where it's showing the container vulnerabilities. And I find this view within this tool really, really not useful, in the sense that it's really just showing you what CVEs exist on the images. But if you were to try to actually fix any of these things, so take this for example, where if we're trying to fix any one of these issues, whether it's with our Juice Shop deployment, whether it's them detecting their own images, really I have very little information about where this is coming into the image. I just know that this thing exists on the image. But if I were to try to patch it, try to figure out where it came from, try to look at the layers of the image, look at the Docker file, there's really not a lot of helpful information here. And so I think a lot of these tools, this is a problem. Now, if we go to the RBAC visualizer, this is where we are using service accounts with the ability to create additional service accounts. And so here on this screen, it looks like it's showing us every different service account that exists within Kubernetes, as well as the permissions of what it's able to do. And so this is actually a really cool feature. I wish that the alerting was tagged more clearly to this, because I know there are some issues here. And I think that's the service account missing. But let's hop back into the controls here. And what's weird is that service account missing is actually not getting flagged on the compliance scanning. It's only showing up in the dashboard. And so let's take a look at what happens if we actually try to load a fix for this. Just getting a look at the YAML file directly, and it does show you, which is really nice, exactly how to set the limits in terms of where those should get set. So that was for their own system, but if I go into Juice Shop here, I can take a look down at setting these limits. And so what I want to try doing here quickly is actually setting these limits up and taking a look at what the rescan is like. How can I tell that this has been fixed, right? So let's pretend I've generated a ticket based off of this finding, sent it to my DevOps team, and now I want to go ahead and implement a fix. So here I am going to set limits in here for Juice Shop, and then go ahead and redeploy my deployment and hop back, and let's go ahead and run a rescan and just take a look at if it tracks, you know, this is a resolved issue now. Things like closing a ticket if I was actually managing this at a large scale. Looks like I can schedule scan, so I'll go ahead and kick this scan off and see what it looks like when it completes. While that scan's running, let's take a look at the pricing here just to get an idea of how they charge. So it looks like the free version is for up to 10 worker nodes, and the team version is for, in bundles of workloads, $23 per node per month is not the most pricey of vulnerability scanners, but it is definitely something worth considering. I want to pause for a moment and notice here that it did see on the rescan the application credentials and configuration files. We'll go ahead and hop back to that in a minute because I want to check how it tracked the memory limits being added from the last change. But you may have noticed on that YAML, we hard-coded AWS access credentials intentionally as a security measure, because that's kind of a weird thing to catch, right? That it's a common practice that people are hard-coding these keys into their YAMLs, but it's not a strictly Kubernetes vulnerability, but it is appearing in those same YAML files. So a great catch here on the rescan. I'm not sure why that didn't show up the first time, but we can see here that it corrected the memory limit issue. So if we hop into the memory issue now, we can see that it did make the issue disappear, but it's worth noting that it doesn't look like it tracked it as like a resolved issue. The total issue count may have gone down, but there's no like internal tracking in the tool itself for things like resolving these issues from a workflow perspective. You can also notice here our AWS access key that it seemed to catch on the rescan. Let's go ahead and hop into that now and see what that particular issue looks like within here. All right, so here we can confirm that yes, it's seeing the access key ID and the secret ID. It's obfuscating the value, which is always nice, and so that's a good find. That's something that most of these scanners that we're going to look at when we look at some of the open source ones are probably not going to see that one. Just checking here for the other issue that we've hard-coded here, which is where the SA account has access to create other SA accounts. So this Juice Shop role has access. So that's this service account token that is mounted. So it's seeing the issue on the dashboard, but it's not seeing it within this compliance page, which is interesting. But essentially what that's allowing is that service account that's running on that pod has the ability to create other service accounts. And so it's just weird that it's not showing up here, but it is definitely showing as an issue on the dashboard page. So something else we've done here is opened port 22 on Juice Shop, as well as bound the docker.sock to the host path. And both of these things are pretty big issues. The first, adding port 22, is just, it's not technically a security issue by itself. It's just, I'm wondering if the application is going to consider that as probably a misconfiguration that we're allowing port 22 open to the internet, essentially, if we were to actually deploy this. And then the Docker mount is, if an attacker were to gain access to this, they could use that to look at all of the Docker streams running on the host. And so this is a very insecure method to look at what other containers are doing, and it's an extremely insecure path. So we're going to redeploy it with these changes. And here we can see that it is finding that host path mount, and that is where it is showing the Docker socket. So it has 2 alerts for that, so that's great. That's a very insecure deployment. But it doesn't flag the port 22 because, again, it couldn't really know that's a security issue. I'm just curious the amount of context that it's really driving up as far as the rule engine. But here we can see that it really caught a lot of our tests. And so it caught our hard-coded environment variables of AWS access keys. It caught our insecure cluster role binding. It counted us mounting the Docker socket. It didn't count exposing port 22. And then the deploying Ubuntu, that's something that we're going to do a little bit later from a runtime perspective. But it's important to note that if there was some sort of runtime credential leak here, where say an attacker got access to Kubernetes credentials and used it to try to deploy their own resources like a crypto miner, that there would be no real-time detection or prevention of that from something like Armo. So now we're going to take those same 5 tests and apply it to a new repo, Kube-bench. This is one of the first scanners that existed out there. It was created by ArmoSec and open sourced from their beginnings, and I don't believe it's maintained as much as when Aqua was primarily open source. Now they're a lot more focused on their paid platform, but still, this is the open source project I've used the most for scanning myself because it was one of the earliest for it. So here it works a little bit differently. We're creating a job.yaml, which is going to, I'm assuming, run a Kubernetes job, and then the results are held in the logs of the pod. And so thinking about how you would deploy this at a larger enterprise scale is you would probably go ahead and run this as a cron job and then send all of the output from those logs via your SIM into some kind of dashboard within your SIM, or create some sort of other more custom solution if you're sending your logs to Prometheus. Either way here, that was very easy to run. The job's already completed and it has already set out the output here. And so all we have to do is, let's take a look at the warnings to see what it caught from our testing. So it appears that most of these warnings are looking for general practices. This wildcard use in a role is what we are technically doing here for this second test of the role bindings, but we could do it without the wildcard, and so that's definitely not something that is a necessary catch. It did happen to catch it, but it wouldn't guaranteed catch this. Here it's making assumptions about image vulnerability scanning, that clusters are created with private, talking about admission controllers. So here it's noticing a lot of things that are insecure about our overall EKS configuration, as far as we're not enforcing a lot of policies. But what it's really not noticing is much of the specific tests that we've done within our YAML. And so it's noticing general things about the Kubernetes configuration, but I'm not sure that it's even really looking at the YAML files itself. I think it's much more scanning for the presence of these things within the cluster. And that just has a lot lower level of usefulness. It's a good guide for creating clusters with best practices, but it's not something that you can really use at an enterprise scale to get good results, to check that you have secure deployments within your YAMLs the way that we were able to do. Here I'm going to add one more test that I should have added earlier, which is just setting privilege containers equal to true. And I'm just going to run this to see if this catches that. And then I'll go back to Armo as well for this one. This is just to check that this is a very common lowest common denominator test, is why I'm doing this, because privileged containers have the ability to access the node. And so everyone knows that you shouldn't be running containers this way anymore. And we're just going to check. It's a good baseline just to see how that gets surfaced, because almost every tool I've used catches that. So let's delete this job and recreate it. So here we are going to just check the logs to see if it caught it. And it looks like it does see to minimize the admission of privileged containers. I'm not sure if it's seeing this specific one or if it's just saying in general that we are allowing it. But if I hop back into Armo, I'll run a rescan as well just to check if it catches the privileged containers. And we can see that as we expected, it does see the privileged container running here. And it is showing us presumably straight in the YAML file where that's coming in, as well as some additional details about how to fix it. All right, now let's take a look at the open source version of Armo, which is Kubescape, just to get an idea of what's the difference between the paid version versus the thing we can use for free. So we can just use this curl script to get started. Kubescape is installing locally. So it looks like Kubescape uses my local kube control credentials to go ahead and run a scan. And here we can see a couple different criticals, which it's interesting that those didn't show up on the compliance scan, but it sees the host path mount, it sees the privileged container, it sees the application credentials in the configuration file. So it seems like it is finding everything that's there. And if we run it in verbose mode, so it looks like the open source version finds all of the same things running from your command line, but is not actually deployed in cluster with the GUI to manage everything, which is definitely a nice feature to take you directly to what's broken. If we run it in verbose mode here, you can see that it's actually showing the same fixes as well. It's just a little bit harder to get into the YAMLs themselves. All right, finally, we're going to take a look at a tool I haven't used before called KubeAudit. And this is something that Shopify built as a way to audit Kubernetes clusters. It looks like for this one, we pass it a path to a YAML file directly. So I'm a little hopeful that, unlike Kube-bench, it's going to actually look at the YAMLs that are getting deployed themselves. Here, take a look at what it found. So we see app armor's missing, which is another general configuration issue. It's using the default service account and mounting it, but it doesn't see that it has the ability to create additional service accounts. It's just seeing that I'm using the service account. It sees that I'm mounting the Docker sock. It sees that the pod is running in privilege mode, but it doesn't see that hard-coded environment variable, the port 22, or really the cluster role binding, and the fact that it allows specifically creating additional service accounts, not just that it's the default service account. And what I wanted to highlight about auditing each of these different tools is if you just look for something like, what's a Kubernetes compliance scanner, you're going to get a lot of different results depending on what those tools are looking at and how they're deployed. So for Kubescape, we saw that it's running via the context of your terminal, and it's using the kube control permissions that you have to scan the YAMLs themselves, as well as in their deployment state, to figure out and reverse engineer what are some of the things that you've misconfigured within this cluster. Armo deploys as a daemon set with a lot of functionality you're spinning up within your Kubernetes cluster, but as a result, you get that nice GUI to manage things. It's taking you directly to where in the YAML to fix things. You get the vulnerability scanning and the RBAC visualizer that help solidify the whole picture and give you that visual analysis. Kube-bench seemed to just be looking at the deployed cluster state itself without diving into the specifics of the YAMLs, because everything it found was more like general configuration things, like you don't have an admissions controller policy, or you're not using an image repository. So just high-level configuration things without really looking at the details of the deployment. And finally, KubeAudit seemed somewhere in the middle, where it was looking at the YAML and actually caught a lot of the things and was running in a way that's very similar to how Kubescape runs, and seemed to be another great open source alternative. Again, this is important because you could think the entire time you're checking this box, right? Do you do Kubernetes security scanning? You could say, yes, we use Kube-bench, we use any one of these tools, but if it's not configured properly, and if you don't really understand what it's doing, you're going to have a hard time being able to tell, are you getting actionable results from this, or are you just using it to check a box that's pretty meaningless? As for my overall thoughts on the tools, I definitely think Kubescape, both from an open source perspective and from a paid perspective, is the de facto tool to use. So even if I didn't use the Armo paid platform to manage my cluster configuration, to look for compliance violations of how the cluster is configured, Kubescape, as far as open source compliance scanning, seemed to be better than Kube-bench and KubeAudit. KubeAudit was a great tool. I really think that it caught most of the things. The key differentiator is that hard-coded environment variable. That's the thing that really shows an attention to detail that only Kubescape seemed to have compared to the other open source tooling. And as for the Armo platform itself, I'm a little bit torn because I do think it's really good at general cluster scanning. However, I would be really hard-pressed to use it for the other two use cases that it supports. The first being the image vulnerability scanning. Those results were totally useless to someone who's actually trying to remediate these issues. Yes, it can develop a bill of materials. Yes, it can help you find CVEs on your system, but it's not telling you where they're coming from or really in detail how to remediate them. And for that reason, I wouldn't really use that piece of the platform, which plugs into the registry scanning as well, just not getting a ton of use out of that. And then the RBAC visualizer did have some nice queryability to it, but since the alerts weren't tied back to it in a way that shows, here's your chain of credentials and how someone could use them to escalate from one to the next, I really think it's more in like a beta state where I imagine what they want to do is create alerting out of how those roles are created and the chain of custody that exists there, the chain of authorization that exists there. Really just the ability to query in general. Most of the time you're too busy to just be sitting around looking to query things. And so really needing to raise alerts is a better way to handle it. Another important thing to think about with Armo is the category as a whole. Most CNAPP vendors will also look for Kubernetes misconfigurations, image vulnerability scanning, RBAC visualization for Kubernetes clusters. And these are additional features within those platforms. But those platforms on the trade-off can also be cost prohibitive. And I look forward to diving more into that category in the future, assuming we can get set up with accounts for them. Because I appreciate about Armo is that I was able to just get started on this video and there was no paperwork or demos or sales process to go through. So this was the first video of this type where we're really looking in depth and comparing different tools within this category of Kubernetes compliance scanning. On the next video, we're going to look at some different container runtime solutions and approaches to, if I do something like spin up an Ubuntu pod, how am I going to detect attacks that someone might be using? How am I going to detect if someone actually takes over a container and uses it to try to pivot into other areas of the environment? So that'll be the next video. If you want more details on any of these tools, you can head over to list.latio.tech. We're also building out some additional functionality to surface the results of this testing across a wider variety of tools. So I hope that you'll like and subscribe. It really helps both me out and you'll be able to stay up to date as we continue to test additional tools in this category to give you a clear view of what is actually happening with them. Hey everyone, Future James back again, and I realized I was about to post the video that I didn't test ChatGPT. And so in order to do that, we will go ahead and add our juice shop YAML in here and say, I have deployed this into EKS. Please find all of the security issues and let me know what they might be. So here, ChatGPT actually didn't do that great of a job. It found the hard-coded credentials, which is great. The image being from a public repository, I actually personally don't view this as too big of a risk, but it is technically an issue. And then it identifies that my resource limits that I set are very weird. It's, I think, what this is alluding to. And then once it did more analysis here, it just found there's no readiness or liveliness probe, and then no network policies. These, again, are more general configuration things, but it didn't mention anything about the cluster role binding, the insecure socket mounting, the port 22 exposed, the privileged container. So really, it seems like it didn't catch a lot, but I'm noticing in here, it did like a Python script to check for some things, and that might have confused it using the code analyzer. And so I'm going to go ahead and just copy paste it. in here and see if I get a different response. If I say, all right, so it did find better results this time when we just pasted the query in instead of using the code analyzer. Here it found the AWS access keys, it found the privileged containers, it found the Docker volume mount. It noted specifically what we thought it was catching about the resource limits being weird. And here is what's interesting. This is the only tool that has caught the port 22 because of that general, more broad context that it's looking for. So this is really impressive from it. It's noticing that I did volume declarations onto the services, which obviously doesn't make any sense to do, but I just did it in order to test how the tools made sense of it, if they flagged misconfigurations or if they saw it as a security issue. It does catch that the permissions are overly broad, so it does say that it can do almost anything in the cluster. Yes, so ChatGPT is actually the only thing that caught everything. And so once again, it's pretty scary that ChatGPT always does a better job than these expensive tools.